Assalamu alaikum, participant. I hope you can hear me clearly.
Yes, ma'am.
Today we are going to teach you
मैम आपकी आवाज नहीं आ रही है।
कुछ लोग तो कह रहे हैं आ रही है।
जी अभी आ रही है।
अब आ रही है।
जी जी अभी आ रही है।
ओके सो ओके हाँ न्यूज़ में भी अच्छा स्टूडेंट्स प्लीज वी आर गोइंग
मैम आपकी आवाज ब्रेक हो जाती है बीच में जो है ना नहीं आती।
ओके वी बोलो दोबारा। अच्छा कॉन्स्ट्रक्ट वालों से पूछना चाहती हूँ अब आवाज आ रही है क्लियरली।
जी अभी आ रही है मैम।
Participant, I hope you are fine. We are going to start our NMR recording of the ethyl.
मैम फिर जो है ना वो ब्रेक हो गई आवाज, कभी आती है फिर जो है ना।
Okay, we are going to arrange a mic. So till then, we can wait. I have asked the IT person to arrange a mic for this class. Uh, अब आवाज आ रही है क्लियरली?
जी अभी क्लियर है मैम।
अभी क्लियर है, ठीक है। मेरे ख्याल से अब शायद प्रॉब्लम नहीं होगी, हम लोगों ने कुछ किया है। तो लेट्स स्टार्ट अवर टुडेज सेशन. So today we are here to run the NMR sample for the molecule that is ethyl benzene, and I'm going to show you how we can run an experiment using the glucose top spin. Okay, so I think you are now familiar with the instrumentation of this machine. We have a large magnet, and today we are going to run the experiment on the 500 megahertz. If we can show you, there is written the Raman frequency on which you are running your experiment is written on the magnet. It is behind this camera, that is, it is 500 megahertz machine. So how we run the experiment? For this, I have to show you first the top spin software, using which I will give the command to for the sample inlet, so that we can inject our sample inside this machine. But before that, I would like to show you that see that this is 500 megahertz machine, and beside this, we also have a 300 megahertz machine. So Dr. Humaira is going to show you how you have to place your sample inside this machine. But before that, you can see that we have a black object on the sample inlet position. First, we have to remove that. So kindly remove that, Dr. Humaira. After it is removed, I'm going to share the screen of the TopSpin software. Where I'm first opening the BSMS board, from where I will give the command to lift the sample inlet.
Okay, I think first we'll prepare the sample. We already have a prepared sample, that is ethyl benzene. Okay, this is a standard sample. And before that, I would like to show you this gauge. This is used to basically check the volume of your sample, because the volume of sample is very critical to perform NMR experiment. So how we do that, how we check that the volume of our sample is fine. We have different kinds of tubes. 3 mm and 5 mm. This is a 5 mm tube.
This is basically based on the diameter of your probe. Right now we have the probe of 5 mm. So we are going to use the NMR tube that is specifically for your 5 mm probe.
Okay, so I am now showing you how you can check the level or the volume of your sample. This is the NMR tube which has ethyl benzene in this, and this is the holder. I'll gently put this tube into the holder, and then with the help of this gauge, which has different kinds of levels mentioned on it, I hope that you can see these. Okay, it's written 2.5, 3/5/8 and 10 mm. These are different sizes of the NMR tubes. So right now I have the 5 mm tube. I'll put this sample tube inside the gauge and I'll press the holder down. There should be no gap between the tube and the gauge, between the holder and the gauge. Okay, and the tube, the sample tube should touch the tip of this gauge. Okay, and then you can see the volume of your sample. Here we have a line, a border line that is showing the minimum amount volume of sample you should have to perform the NMR experiment. So right now we have proper amount of the proper volume of the sample. So we are ready to put this sample tube inside the NMR instrument. And how we will do that? We first take out this tube and we will use a tissue paper. Okay, because I have touched it with my fingers. So I'll just wipe the holder. And Dr. Sumaira will now press the lift button.
I'm going to share first board.
Yeah, the BSMS controls.
And here you can see different commands. We will just lift the sample.
That will generate a vacuum. So if you will not press the lift button, there will be no vacuum. We'll insert the tube and it will directly go down into the NMR magnet and the tube will be broken. So it is very crucial step to press the lift button. And as soon as you will press the lift button, there will be a sound of vacuum generation inside the tube and now inside the NMR. And now I'm going to put the tube inside it. Stop.
So again, we have to press the lift button so that the sample can go down into the probe head. And you can see the status of the sample will be changed here. Right now, it is in between the up and down state. And once it settles down, it will be showing the signal of green color, which which will tell you that the sample is now at the probe head. And you will also see when the sample is settled down, you will see a signal like this. After that, what we have to do is we have to follow this sequence of steps which are here. First of all, you have to create a data set which will be used to perform the experiment. That is, create a data set. For that, we need to give a command that is EDC. And here you have to give the information about the experiment which you are going to run. You have to write the experiment name. Today we are on 21st of October. You can give the name to the date. You can write the name of the sample, whatever you feel comfortable for your sample. This is experiment number 1. Directory will be the same that we are using. There are different parameters which you can select according to the experiment which you are going to do. The sample is dissolved in chloroform. So this is ethyl benzene. So now the experiment has been created, and after that we have to lock our sample to the solvent in which we have dissolved our sample. Series of solvents which are available, and here you have to select the chloroform. Once you select that, you will see the lock line of the sample here. You need to see this lock line. It will be done by your machine. We usually lock our sample to minimize the magnetic field inhomogeneity, or to see that magnetic field during this experiment is uniform, is homogeneous or not. Once it is completed, you will get a message from the software that it has been completed. After that, you have to give the command of tuning and matching. Here in this system, we have an automatic system to tune and match the sample. So I'm giving the command of ATMA, which will perform the tuning and matching of your sample according to the experiment type you are performing. It basically helps to maximize the signal that your sample is receiving the right radio frequency once it has received that radio frequency. You will see the signal of tuning matching here. So it is done. When you don't have that automatic system of tuning and matching, then you have to use a different command, that is walk, and then you have to do it manually. After doing that, you have to perform shimming. Shimming is also one of the way to minimize the magnetic field inhomogeneity during the acquisition. For that, I'm going to use the command top shim, and you will see the progress of that here. You have to wait 1 minute or little more than that to let it complete. Okay, once it is done, you will see a message from the software that the adoption process has been completed. After that, you instrument as it has already been connected, so I'm not going to perform this experiment, this step right now. After that, you have to do a command of RGA which will ensure the maximum receiver gain to the sample and the maximum signal will be obtained from your sample. It will receive the maximum radio frequency and it will give you the maximum relaxation, or you can say the signal which you need. It is done, and after that I'm going to show you a window that is acquisition parameter. Here you can see, okay, this is the pulse program that Dr. Iqbal mentioned to the NMR experiment which are being built by the Bruker library. I'm going to perform the proton NMR, and for that I'm going to use the pulse program ZGESGP. So I'm looking into that. This is ZGESGP, which is basically a proton NMR along with the water suppression. Set pulse program, click that and close it. Okay, now you can see that this program has been settled here. Now you have to perform the get result. Why? Because previously I have taken the data from an experiment that was only protons. It was not with the water separation. As I have changed the pulse program from ZG to ZGESGP, so now I have to perform the get result. Okay, after doing that, I'm going to run the experiment with less number of with one number of scan, and then we will increase the number of scan to see the difference between between the experiment that has been run with one number of scan and with more number of scan. Here you have to remember that Dr. Iqbal told us that between each scan you can provide a delay, or you can provide a D1 of 1 second, or you can give a delay of 5 seconds. As right now I just have one number of experiment and 4 number of dummy scans, so I can give it a command of a number of 5 seconds. You have to perform RGA again. So I have intentionally changed the value of RGA to show you the difference. I'm now going to give the command of ZG that will run the experiment, and then we can process that. You can see the progress of your experiment here. that the residual time to complete this experiment is 29 seconds. After that, you have to give the command of EFP to see what's going on. See, this is the result of our experiment. This is the FID which Dr. Iqbal has shown you or discussed with you so many times. And you can see the spectra is so much disturbing. The reason why because it is, I have intentionally increased the RGA value myself, which is 101. Now what I'm going to do, I'm going to give a command of RGA again and let it decide itself that what should be the good RG value for this sample. And then we will run this experiment again. Again, the command ZG. Okay, now when your experiment is complete, you will see a message from the software that 1D raw data is available. You have to give the command EFP and you will get a spectra like this. Before you have the spectra in our previous experiment where I have given the RGA intentionally different. It was like this, and when I okay, as I have just shown you two experiments. In the first experiment, I have changed the RG values myself, and you got a result like this. Group, you have a ethyl group where you could get the NMR signal for methylene and methyl. And then I decide this machine to do the RGA itself. It gives you a much clear spectra, which is more easily interpretable. Here you can overlay the two experiments as well. This is the second experiment which with the RGA that has been automatically settled by the instrument. And this was the one that has a different RGA value. You can clearly see the spectra which you recorded the second time is more clear. Now I'm going to run and create another experiment where I will be giving more number of scans. Before I was giving one number of scan, now I'm giving it 16 number of scan. It will increase the signal to noise ratio. So let's see that. Again, I have to give the command ZG. And you will see the progress of your experiment here. Before, it took just 35 to 40 seconds to complete the experiment. Now, as I have screened the number of, increase the number of experiment, so it will require 2 minutes and some seconds to complete this acquisition. uh, from this to this level, it will show you that there is something wrong during the acquisition, or the magnetic field drift has been occurred. So this is like, you can say, a signal to ensure that your sample is having a homogeneous magnetic field during the acquisition. So again, you can see, you will see have a message from the software that 1D raw data is available. You have to give the command EFP. It will process your spectra. Before you had FID, and now you have that Fourier transform version of this spectra. After that, you can correct the baseline of this spectra by giving a command of APKS and ABSN. And now you have to integrate. But before that, I would like to ask you, for this molecule, how many signals you will expect? You have a molecule of ethyl benzene. Please tell me how many kind of signal you will expect for this molecule. RGA is receiver gain. The baseline can be corrected by giving a command of ABSN. Please, student, I have told you that the molecule which we are running is ethyl benzene. So how many kind of signal, how many NMR signal we can expect for this molecule? Okay, good. We expect three signals. The first one is for methyl, the second one for methylene, and one signal for the CH group that are present in your benzene ring. Good. Now we have to interpret our NMR. If you remember, Dr. Iqbal told us that you have to integrate your spectra, and you have to find out that in your NMR signal how many kind of proton are present. So if you are with me, please tell me, based on the n+1 rule, for methyl what we can expect, a doublet, triplet or quartet. Please tell me, you have a methyl group which is associated with a methylene group. As it has two proton associated with it, it will be appearing as triplet, okay, not quartet. The methylene will appear as quartet because it has 3 proton in its neighbor, while the signal of CHS, as they are present in your aromatic ring, they will appear like a complete multiplet. So let's integrate your spectra. And we also know that for the alkyl group or for the aliphatic group, they usually appear upfield. So we will zoom in this part, and you can see that you have a triplet. So this most likely to be a signal of your methyl group. For that, we have to analyze. You have to click here, and then you have to completely cover this signal and automatically calibrate, as we are expecting a triplet for the methyl signal. So we can the other one. For the methylene group, we are expecting a quartet, and here we have a quartet. You can see it clearly. So what you can do is you can integrate this signal as well. If this should be 4 or near 4, sorry, 2. You are having an integration of 1.72, which is near to the 2. So this signal has a proton of 2, indicating that this signal is of your CH2 groups. Now we are moving to the aromatic region, where we have the signal for our benzene, methyl green groups. What you can do is you completely integrate this signal, and you expect 5 proton in this signal, and you can see when we integrate that, we got around 4.62, which means that this signal is actually coming from your benzene or aromatic part of ethyl benzene. When you have done with this integration, you have to click save and return. If you don't want to save this integration, you simply can return. But if you want to save, you click this signal, and once it is done, you have to plot your NMR spectra. Here, okay, you can see your complete NMR spectra is available here. Here you have the proton NMR scale. Here you have the information about the acquisition parameter that you have used to run this experiment. You have the date, you have the NMR machine, Lama frequency, and different parameters that can help you to analyze or to identify that what you have done with that. After that, you are done with that, you have to remove your sample from your instrument and you are ready to run another experiment. Also, I'm going to show you the difference between the one number of scan and 16 number of scans. So this was the red one is the experiment that has been run with only one number of scan, while this experiment has been run with pure signal. So this is the advantage of having higher number of scan to increase the signal to noise ratio. And I have also shown you if you have a wrong RGA, what could be the appearance of your NMR spectra. You can see the unwanted signals which should not be present if your receiver gain is okay. So this is all from my side. I can now take your take your questions. Okay, there is one question from that. What determines the number of scan of a sample? Usually, if the concentration of your sample is very low, you should have high number of scans. But if you have a strong sample, like you have 1 mg or 1 millimolar, then it is okay if you go with 4 number of scan or 8 number of scans. It depends on the strength of your NMR sample, strength of your NMR sample. For the proton NMR, you can have 16 number of scan, but if you are 313 is very less, and to have the signal, you have to have the high number of scans. Okay. RG, I just told you, RG has basically appeared. It has nothing to do with the quality of scan. It just give you a representation of your spectra. If I show you again, the overlay of two experiments with the correct RGA and with the wrong RGA, you can clearly see the difference. This is the experiment with the RGA automatically settled or adjusted by the machine. And this is the spectra that has a wrong RGA. You can see the difference between the two. Okay. What is the importance of, okay, the importance of using deuterated solvent is that if you don't use deuterated solvent, you will see a high signal of your protonated solvent, and in that case the signal of your your sample will be small. So you don't want to have the interference of your protonated solvent. This is why you use the deuterated solvent, and it also helps to identify the magnetic field stability during the acquisition. If something bad or something some changes happen during the acquisition, you will see a drop in this line. This line basically give you the indication that the magnetic field was stable during this acquisition. But it is affecting the quality of skin. It actually, I think you are asking about the RGA. RGA basically affect the quality of your NMR spectra. Okay, you can ask me a question if you want some more. The splitting of this molecule is clear to everyone. If you have any question, do you have? Okay, if there is no more explanation, and I'm going to tell you again. Okay, whenever you are setting the parameters, you have to select the best pulse program according to your need, and then you have to adjust the P1 value, and that value basically determine using various parameters, Humaira. Okay, and you also have to run first the experiment using the parameter which are default in your which are being provided by your Bruker library. They are mostly optimized according to the solvents, and if you got a nice spectra, you don't need to change that. But if you think that you need to improve that, you can change the P1 values. Basically, the number of scans, dummy scan, RGA, P1 are the parameters which should be considered while running your NMR experiment. It is always good practice to use the default parameters which are present in your Bruker library. You just need to connect the system or the computer system with your NMR machine. Any other question? Okay, I'm also going to tell you that if your sample is not pure, the only option is to pure it. Okay, because if it is not pure, you will get so many noises, or you will get so many unwanted signal. To avoid that, you should purify your sample, because the impurity cannot be increased or decreased by increasing the number of scans. Another thing, that there are different NMR and sample running tutorials available online, which you can go through, and then we can discuss them further if you want. Any other question? Okay, if you don't have any other question, I can end this meeting. What is the maximum amount required for? Okay, for the NMR machine, you can go for 1 mg or 0.5 mg. You can record the NMR spectra if you are running the proton NMR. But if you are looking for a C13 NMR, the only thing is to increase the quantity, or you can increase the number of scans. This will have a longer time duration. So 0.5 mg, 0.25 mg is also okay if you are intending to do the proton NMR. On maximum, if you go like whatever you have, you can run that if you want to waste the sample. How can run a peptides? Okay, the raw venom peptide, if it is soluble in any buffer, the aqueous buffer, you can simply dissolve that into any deuterated aqueous buffer and then run the proton. You don't have to do anything else. Just if your protein, try to dissolve that peptide powder in that solvent and run for that. If your sample is soluble in what, I think you can proceed as we have done in this case. There is no difference between the NMR sample preparation, whatever you are running. Only the solvent can be difference. Buffer is basically required to maintain the solubility and the biological function of your बायोमोलिक्यूल. आपका बायोमोलिक्यूल किसमें सॉल्युबल होता है? इट इज रिक्वायर्ड फॉर दैट पर्पस. You can use tris buffer, phosphate buffer for this purpose, but in that case you need to use the deuterated salts. Any other question? Okay, I think we don't have any more questions, so I'm going to end this meeting. Thank you very much. And